Okay, middle of problem 3. Actually, I started it already under problem 2. I should do these separately and keep them short. So number 3 here, we're working on domain and range also on this. Initial observations, we can't divide by 0, so the denominator can't be 0, which leads us to z not being negative 1. And the inside of the square root, again, the thing inside there can't be, well, it has to be greater than or equal to 0, so z is greater than or equal to negative 1, but it can't be equal to negative 1. So from negative 1 to infinity is the appropriate domain from that. Range is not nearly as obvious. You do have the observation here that since this is always positive now, negative 4 divided by that is always going to be negative. But can we get just any negative number, or what can we possibly get here? And let's take a look at this. So we got to think about what happens with some different values in here and try to get a sense of what's happening on the graph. I know it's always going to be negative, and the domain being from negative 1 to infinity means that here at negative 1, it's never going to reach that. So the whole graph has got to be down here somewhere, but I want to see if it covers every negative number from negative infinity to 0 or what. I kind of want to get a sense of that from the graph and think about what's happening. So let me try some values in between there from 0, 1, maybe 5, 8, things further out, and think about those as inputs. What happens when I substitute those in? So if z is 0, you get negative 4 divided by 1. If z is 1, you get negative 4 divided by square root of 2. Comes out, I think, somewhere around negative 2.8, something like that. Z is 5, I get negative 4 over square root of 6. Didn't calculate that right. Let me see what these come out to. I didn't pick out numbers that come out nice, but I can work this out. And I just want to get a sense of the graph, so I just want approximate values. 6, I get negative 1.63. Z is 8. It does come out nice, negative 4/3, so it's like this. I'm kind of getting a sense of what's happening. Well, if I put those on the graph, I will. So it's here, and it's up here, here, way out here. I don't know, am I getting to negative 1 out here? Let's see what happens with really, really large numbers. So I want to see what happens when we approach, when we get way out toward infinity side. My domain's going all the way to infinity, so I want to see what happens that way. And I want to see what happens when I'm really close to negative 1. How far down does it go? But if I'm really close to negative 1, I'm dividing by something tiny, and that's going to get really, really big negative numbers. So this is really going to keep going in that direction. You've seen vertical asymptotes before. That's what happens when you have a 0 denominator. So when z is approaching negative 1, we get a asymptote there. We're going to talk a lot about that kind of behavior in calculus. What happens is you're getting close to something on there. That's going to be some of our limit stuff. So that's important. We will see what happens with that. And then what happens when z is going out here toward infinity? So if I just pick like a gray big number where this will come out nice, that would be negative 4/10 or negative 0.4. So it does just keep staying negative but approaching that thing. So from that graph, I get a sense of the range being, well, what y values do I end up using? It's going all the way to negative infinity if I kept going that way. And it looks like it's coming up and approaching 0 on this side. Never going to hit it. So from negative infinity to 0, it's never going to be equal to 0 because you can't do negative 4 divided by something and equal 0. But from negative infinity to 0 is good. That's wrapping up problem 3. I do have one more I want to get to on this document.